Today I will be talking about perfectly inelastic and elastic collisions in physics. Perfectly inelastic collisions occur when two or more objects collide and get stuck together, ultimately moving together as one mass in one direction with one velocity. In these types of collisions, the kinetic energy is not conserved. Instead, it's converted to sound and internal energy due to the deformation of objects. This is the equation for these types of collisions. As you can see, in the beginning, there's two different objects with two different masses and two different velocities. However, after the collision, they ultimately become one object with one mass and one velocity. The variable m equals mass and the variable v equals velocity. This example reads, a 95 kilogram fullback moving north with a speed of 5 meters per second has a perfectly inelastic collision with a 90 kilogram opponent running south at 2 meters per second. Calculate the velocity of the players after the tackle. We'll be using the same equation as I showed in the previous slide. However, we will need to rearrange it in order to solve for VF, or final velocity. But before we do that, let's look at our givens. Mass 1 equals 95 kilograms, mass 2 equals 90 kilograms, V1 equals 5 meters per second, and V2 equals 2 meters per second. After you rearrange your equation, it should look something like this in order to calculate the final velocity. Then you plug in your numbers to read 95 kilograms times 5 meters per second plus 90 kilograms times 2 meters per second divided by 95 plus 90. After plugging all this into your calculator, you should get a final velocity of 3.5 meters per second. Using the same problem as before and the same numbers we calculated, I'll be proving how kinetic energy is lost in perfectly inelastic collisions. The formula to calculate the change in kinetic energy is KEF minus KEI. Kinetic energy is found by doing 1/2 mv squared. So first I'll be using mass 1 and mass 2 with V1 and V2 in order to find the kinetic energy initially, which equals 1368 joules. Then I'll be using mass 1 and mass 2 again. However, I'll be using 3.5 meters per second, which is the velocity we just calculated, in order to find the kinetic energy final, which equals 1133 joules. After plugging it in to this equation, I got an answer of negative 235 joules, which is the amount of kinetic energy that was lost after the collision. The other types of collisions are called elastic collisions. This is when two objects collide and return to their original shapes. In these types of collisions, kinetic energy is conserved and so is momentum. This is why the equation is the same exact one as the conservation of momentum equation. The example for this reads, a 0.5 kilogram soccer ball collides elastically in a head-on collision with a 0.4 kilogram ball. The first ball starts at rest and the second ball has a speed of 3.5 meters per second. After the collision, the second ball is at rest. What is the final speed of the first ball? So first we look at our givens, which are these values, and then we will need to rearrange our equation in order to solve for V1F. And then you plug in all your numbers, and you should get an answer of 2.8 meters per second.